And so we are going to take a very focused approach, which is we'll show you a very particular set of tools in Amazon Web Services, which is, the largest cloud provider out there today. And because it's cloud, it also means that, you can go ahead and with your own laptop with a network connection, be able to get yourself an account and then go ahead and actually build everything we show today. So you don't really need, you can bring into your company or into your job or into your private learning these capabilities and practice them without needing a lot of big infrastructure. So we'll show you kind of what you need to do, and then Yamuna will do a detailed demo of how to actually build an AI that you can either follow along directly at this time, or you can watch the video later and get all the steps. So in this workshop, we'll talk about what is the full AI lifecycle, what does it mean to build an AI for business, and then how would you build that lifecycle in the cloud and particularly in Amazon. So let's talk a little bit first about the full AI workflow. Now, this is described in an abstract manner intentionally because this is the cycle that any business that wants to use AI as a technology and make money from it, this is the cycle that they follow. What they do specifically in each step depends upon, of course, what they're trying to solve, but the steps are basically the same. So the first is to identify a business need, which is what is the problem you're trying to solve with AI. And that could be anything from recommending a product to identifying risks to, for example, customers who are going to leave and things like that. Then the next stage is data. So you need to find the data that is relevant to your problem. And this is frequently found inside your company. If you're practicing and learning, you can find lots of public data sets to practice with. Then you train an AI model and develop it and test it. So this is the cycle where you create a prototype artificial intelligence that is, showing in tests that it is capable of making the prediction that the business needed. Once you have something that you feel is good enough that it's doing well in the tests and in the experiments, then you do what is called deploying it. Deploying it basically means that you create a version of it that your business can actually use. So for example, if your goal is to identify customers who are going to leave and then send those customers, some marketing emails or, have your sales team contact them, then deployment means that you've put your AI in a place where your sales team can ask a question like, I have a customer, do you think they're going to leave? And the AI will answer, and then the salesperson can take an action based upon the answer. So once you have the AI built in a way that it's usable to your company, then you connect it to your company. At this point, you have a working AI that your company can use. Then you have to keep an eye on it and monitor it and see whether or not it's actually solving your business problem. Very frequently, what happens is that even if it is solving your business problem, simply by building it, you come up with ideas on how to make it better. So this life cycle typically repeats, multiple times, and how frequently it repeats depends a lot on what's going on in your company, or in your business problem. Some business problems you repeat maybe 2 or 3 times a year. Some things that are like web applications, you might repeat, every 20 minutes even. It really depends entirely on how quickly you want to adjust and what is it about your problem that makes it both necessary or possible to adjust. So these are the stages that we are going to demo for you. We are going to take a problem and we are going to show you how to get to this cycle. Now, a few things about this cycle. Why do we need the entire cycle? Because frankly, without this cycle, you're not going to result in making money, or solving the problem. A lot of data science training focuses on these 3 steps, which are important to learn. But keep in mind that if you're actually going to solve a problem, you do need to connect it to the problem and make it better. So it's very important to be able to do this full cycle. And that's how you generate value for your application or value for your business or things like that. Why is this challenging? First of all, there are a lot of steps in this cycle. That's one of the things that makes it challenging. The second is that as we will shortly discover, these steps don't all use the same tools. And so one of the things that makes it challenging is that even though there's a lot of tools out there, you do need to connect a few of them together in order to get this cycle to work. And that is one of the things that we are going to show today, is how to make the connection. So now let's talk sort of a little bit about AI in the cloud. So there are, many cloud vendors today. The three major cloud vendors are Amazon Web Services, which is called AWS, Google Cloud Platform, which is called GCP, and Microsoft Cloud, which is called Azure. Now there are several other second tier clouds, IBM, Salesforce, things like that. And they also have a lot of AI tools, but for simplicity, we are just going to talk about these three, and we're going to talk about specifically Amazon, which is the biggest one. So if you're interested in sort of the way that this is sort of evolving, Amazon, I believe, is at the moment the biggest one from a pure footprint standpoint, which means that more people are using Amazon than any of the others, but the other two are growing much faster. And so because of that, all three of them are very serious and very important. Amazon happens to be the biggest. In the next few years, that may or may not be the case, depending on how quickly Google grows and how quickly Azure grows. So now, what are the tools that are available? So one of the things, so this is a slide, and we call it the sneeze slide because it looked like you sneezed from here and then tools are just kind of going everywhere. But every single logo here is a separate product from just these three companies. And this slide is about 1.5 years old, and there's likely, I think at this point, twice as many products as there were in the slide when we created it. And so one of the things that makes this space both exciting and overwhelming is that these three companies, when they release products, they don't release one. They tend to release 10 or 15 at a time. And all of these products are very powerful, and they create a really tremendous opportunity for engineers and developers, but they also create this interesting problem that none of them individually fix this cycle. So in order to make this cycle work, you have to go to this stuff and pick a set of tools and connect them together. And so today we are going to connect a few of these tools together and show you, now you don't have to use these tools in your application, but at least it'll give you a place to start. And the tools that we are going to show you are some of the most popular tools in Amazon. So if you follow that, that set of Amazon tools, you won't go wrong. But as you explore more, you may find that there are other tools that, like Rekognition, for example, that might be useful for you. So we'll give you a starting point of tools that you can start with and tools that you can connect so that you can get something working that will set you up hopefully to, to be able to explore other tools in the future. So key thing here is tons and tons of tools, tools for almost everything you can think of, but you need to figure out how to use them. So now let's talk a bit about how we take that life cycle, that circle, and then how do we map it to tools. So we'll start from the bottom up. The first thing is that you need a place for your AI to run. And so that's infrastructure. And all of the clouds provide you with the ability to rent machines, rent storage, rent network, and stuff like that. Then you have to get some data. Now the data, is something that is probably you're going to bring in. But what the clouds do provide is what's called a labeling service. Now, you may or may not need to use this. A labeling service is basically that if the data doesn't have a label that the AI can learn from, they do have services where you can hire humans to inspect your data and label it. We're not going to discuss that today, but it is something you should know is happening. There are some tools that you can use to visualize and prepare your data. Then you have to go through the modeling and the training. You can either use, algorithms that are already available in Amazon, or you can bring in your own. Then there's deployment. And then once you have deployment and you have a working AI, then you can connect up your application. So this is the stack of tools that this life cycle converts into when you try to map it into actually building it. You end up with a stack that looks like this. And then what you need to do is to fill in for each of the levels of the stack. Do I need a tool for that? And if so, which tool am I going to use? So now how does this actually turn out into a flow that you can build? So what happens is that you start with a piece of data. In Amazon, you would put this data in one of Amazon's storages, and we will show you how to put it in the simple storage service, which is the largest unstructured store that they have. Then you could basically have to run some preparation and transformation on that, and that might create a modified or what's called a process data set. Then you bring that into the Amazon flagship AI tool, which is called SageMaker, and this is where you train all of your models. Now, once you select a model, select an AI that you like, SageMaker will create what's called a model artifact for you, which is essentially the brain of the AI. So SageMaker will take the data, it will train, create a bunch of models. You will pick a model artifact. Once you have a model artifact, then it is time to deploy it. And deploy it means make it accessible to programs. So that is done, using an Amazon tool called the SageMaker endpoint. Now, the SageMaker endpoint, what it does is it creates a running service inside SageMaker where you can contact that service with a question, and the SageMaker will use your model to answer the question and send you an answer. Now, a SageMaker endpoint is needed to use a SageMaker model or a SageMaker AI. However, it is only accessible inside the Amazon world. So other Amazon applications, if you have other Amazon programs running around in your Amazon account, they can use this. But if you want an external application like your smartphone or your banking app or whatever it is to contact this, then you have to make it visible to the external world. So the way that you do that is that you use an Amazon product called API Gateway. And what API Gateway does is it will create a connection to the outside world. So anything that's blue here, by the way, is inside the Amazon cloud, and the green, which is a simple, app that you can, use to test, is an external app. So what happens is that when the external app, the API Gateway publishes a web address, and that web address is something that you can then use to communicate. Then you need to use an Amazon product called Lambda, which is also stands for serverless. And what happens is that when a request comes in here from this public web address, this product knows to contact this endpoint. So once you have all of these things connected together, now your AI is accessible to the outside world. So the flow that will happen is that your app, whatever is in the green box, will make a request to the web address that is, that was presented. This product knows to contact this Lambda. This Lambda knows to contact this endpoint, which knows how to use this model. A prediction comes back from the AI and goes back into your app. So this is how the life cycle becomes realized in a set of tools. And so you can see that we are using, about at least 4 different Amazon products here. We're using S3 for storing the data, SageMaker for doing the AI, SageMaker endpoint for exposing the AI, Lambda for connecting it to the outside world, and API Gateway for publishing it to the outside world. So this is what Yamuna will demonstrate today. Now, what are we going to demonstrate this for? Now, this diagram, by the way, could be used for pretty much any type of AI. It is not specific to a business use. It's not specific to a type of AI. You can, whatever you choose to train here in this blue box can be exposed this way. However, the demonstration we are going to do is for a specific problem called churn. Now, what is churn? So many businesses have customers that they want to keep. Customers who may have joined, it could be, banks, it could be people who are buying stuff from your website, it could be people who have subscribed to your newsletter, whatever it is. And some of these people sometimes suddenly leave, and we obviously don't want them to leave. So the idea of churn is to use the AI to try to predict who is likely to leave before they leave. And this doesn't have to be limited to customers. Large companies sometimes use this to figure out which employees are going to leave. Because for them, if they have a lot of employees leave suddenly, it damages their business. So now how does an AI predict whether or not somebody's going to leave? Part of it is that they can use the historical data of people who have left in the past and what they did before they left. So something as simple as maybe this person hasn't been to your website in 3 months. And it looks like people who left kind of suddenly stopped coming to your website. Or maybe they used to consistently spend money with you, and then the amount of money they were spending with you declined. And that was the early indicator before they left. So all of it is really about historical data, and it depends on the use case, but historical data of the behavior of this customer up to the time when they left. So you give that to the AI, and then the AI then learns the patterns that people exhibited before they left. And then it can use that to basically track patterns of people who are currently here and say, you know what, this one is looking risky. You know, they used to come to the website regularly. Now they don't seem to come to the website anymore. I think this person might be gearing up to leave. Might be a good time to give them a call, maybe make them an offer. I give them a free gift, you know, do something to get them to come back before they leave, because after they leave, it's much harder to get them to come back. For an employee, maybe it's something like, you know, perhaps the employee hasn't gotten good performance reviews. Maybe the employee has been asking for things. Maybe they asked for a transfer, did not get awarded, stuff like that. And those can be historical things that develop before the employee decides to leave. So the idea here is that we will provide historical data, and then the prediction will be yes or no, this person is going to leave, or no, this person does not look like they're likely to leave. So that's what the AI is going to predict. So what this translates into is essentially an AI that we're going to build. It's called binary classification, because we are predicting yes, they will leave, or no, they will not leave. So that's ultimately what the AI is going to predict. And Yamuna is going to show you how to link up these tools to build an AI where you can put in information about a customer, and out comes the answer, yes, they will leave, or no, they will not leave. Now, the data set we are going to use is a public data set. It is a data set about a bank, and it includes things like, you know, the customer's credit rating, their gender, you know, how much money is left in their bank, how long have they been with the bank, how old are they, do they have a credit card with the bank, stuff like that. And then we are going to try to predict, you know, whether or not they're going to leave. So exited is I left, exit 0 is I'm still there. So you can imagine that you could have a very similar problem, but this particular data set is publicly available. So all of you can go ahead and build using this data set, and that will show you an idea of how this kind of stuff is going to work. So I'm going to now hand it over to Yamuna, and she will go through, for this data set, how you actually take those steps that we just described. Go ahead, Yamuna.
Thanks, Nisha. Okay. So hope everybody can see my screen. And this is the AI workflow we're going to build today using AWS. And the first step, as Nisha explained, we're going to look at bank churn. So first, I will show you where you can find that data set. So the Kaggle link available here, it's a publicly available data set on Kaggle, so called bank churn modeling. So this is the data set we're going to use today to create the full AI workflow in AWS. And when we get these data, if you look at the data, it's like in the raw format, right? So these are the raw data coming for your end.
Yamuna, excuse me, are we able to share this link with the participants?
Yeah, sure. I will.
On the chat, please. Thank you.
Yeah, sure. Okay, so I will post this into the link in the chat. So this is the publicly available Kaggle dataset. But when we get this dataset, you cannot directly use these data to create the training job. So there, if you look at the flow, there is a step called dataset preparation and transform. So when we get raw data from the outside, first thing you need to do the preparation part and transforming data, which can use to launch the training job. So when it comes to data preparation and transform, there are various things you need to do. So there are some typical feature engineering you have to do, like filling missing values, one hot encoding. So those kind of steps are there. Other than that, there are specific steps related to AWS SageMaker. So the first step, you should move the label column as the first column. So I will show you the data set for the churn modeling. So this is the churn modeling data set, and the label column of that is called exited. So it has 1 and 0, which tell you whether this customer is exit or not. So this label column should be the first column when we are launching a training job using the AWS. So that's the first specific thing to the AWS SageMaker. The second one, we should remove the header. So AWS SageMaker will not accept data with headers. So you should remove the headers and only give the data when launching the training job using Amazon SageMaker. So those two steps are specific steps related to the AWS SageMaker. So when it comes to the data preparation and transform, those things needed to be done. So today I will show you after creating those data sets. So after transforming data, you can generate transform data. So you can use any Python code snippet or anything and do the transformation. So I will give you those data. So this is a transform data, and this is how it looks like. So we should move the label column as the first column. So this is column A is the one exited or not exited. But since there are no headers, it will be really difficult to understand what are these data. But this is how Amazon SageMaker expect data. So we need to go with this format, and label column should be first, and you should remove all the headers, and other feature engineering steps are already done. So I will post these two links as well. So I split the data to two data set called train.csv and test.csv. So I will tell why I did that. So why I did split those data into two. So why cannot use it as one like churn modeling.csv? So we can just use churn modeling process CSV. Why can't we do that? So actually you can do that, but there is a drawback if you do that. So let's say, so I provided those two links as well in the chat for the train dataset and test dataset. And why we are splitting those data to two parts, because when we are launching a training job, how you analyze how better your AI is performing. So there should be some evaluation metric, right? So to get those kind of matrices, we should provide a separate data set to do the evaluation part. So when come to Amazon SageMaker, it will use these two files. So it will use train data set to do the training itself and create the model. And it will use this test data set to evaluate the performance on top of that model using this test data. So after that, it will provide a metric like, let's say, the accuracy. So it will say it has 90% of accuracy, it has 70% of accuracy, likewise. So to get that evaluation metric, we are providing these test data. So that's why we split our data into two parts. And when we are splitting this, it can be done in any percentage, but normally we are splitting it in 80-20. So we will provide 80% of our data for the training, and we will keep 20% of our data for the testing. So that's how typically it goes. So first thing we need to do, now we have a processed file, and we should upload them to the S3. So that's the first service we're going to look at from the AWS. First, you need to upload these two data sets into the S3. So what is this S3? And I will show you. So first thing, you need to go to Amazon Management Console. So I will provide this link as well. So this is the link for Amazon console, and if you already have an account, you can just log into that and it will direct you to the Amazon management console. But you don't have an account, you can simply create a one, but it will take some time to enable resources and all if you are creating it new. Okay. Okay, so first thing, we're going to look at S3. So you can search for S3 from this search bar. Just type S3 and it will show you the S3 service. And you can click on that. So S3 means simple storage service. It's provide you to store your data in cloud. So this is very similar to folders in your laptop, but it is in cloud. So that's the difference. So when it comes to S3, there is something called buckets. So it's very similar to folders, but when it comes to S3, we call them buckets. So when we are storing data, first you need to create a bucket. You only can store data inside bucket. Other than that, you cannot directly upload data to S3 without a bucket. So first you need to create a bucket, and I will click on this create bucket link, and it will direct you to this screen where you should provide a name. Okay, I will give Slascom workshop 1. Okay, other than bucket name, there are many configurations when it comes to S3, but I'm not going to explain all of them, but there are like how to control the access for this S3 and what are the versioning, tags, encryption, and there are some advanced settings like object logs. So when it comes to AWS, they have very good documentation. If you can see, there are learn more links for each and every configuration here, right? So if you want to know about any configuration, how it works, why we are using that, so all things are available on their documentation. It is really good. So by looking at it, anybody can understand what we can control from this. So that's a very useful thing. So today I'm not going to go through each and every configuration. So just I'm giving a bucket name. And when it comes to S3, the next important thing, the AWS region. So when we are using our services, the region is a very important thing. So all services we are created will be specifically belongs to one region. So when we are creating a bucket in this region, that bucket will be available on those regions. So when we create in the AI service, throughout the AI lifecycle, so we are going to use many services, right? We're going to use S3, we're going to use AWS SageMaker, SageMaker Endpoint. But when we are creating all of these things, you should stick to a one region. So if you are choosing a region here, you should stick to that region throughout whole the process. So I'm going to go with US East 1, North Virginia, because it's something very cheaper when it comes to services. So I'm going with North Virginia. According to your preferences, you can use any of them. So I'm just giving a name and keep all the configuration as it is. And I will click on create bucket. After creating the bucket, you can upload your data. So before uploading your data, so if you are using these two data sets which I provided, you should download them to your local machine, because I'm showing you how you can upload it from your local machine. So this is the bucket I have just created. So I will select that bucket, Slascom Workshop 1. And inside that bucket, you can create folders or you can upload directly. So everything you can do. So I will just create a folder as well. I will create a folder called bank churn. And I'm going to select that folder. And now I can upload my data into here. So I click on upload button. And here you should click on add files. And these are my two data sets. test.csv and train.csv. I'm going to select those two and click on open. And after that, you should click on upload. And it will show you the remaining time and upload percentage. So if it is successful, you will get a green color message called upload successful. And you can see the files here after the uploading. So this is the first step. Now our dataset uploading part is completed. Next thing we need to do, we need to launch a training job using AWS SageMaker. So now we're going for our next step, which launching the training job using AWS SageMaker. So I prefer to keep this tab open because I will need these two data sets when I'm creating the training job. Because of that, I will keep this tab open and I will open AWS console in another new tab. And now we're going to go for our next service, Amazon SageMaker. Okay, just click on Amazon SageMaker. And there are many facilities provided by Amazon SageMaker. And today we're going to look at training jobs. So you should click on this training and select training jobs. And here you should click on create training job. And after coming here, first thing you need to give a name. And you need to give a name and you should specify IAM role. So what is this IAM role? So IAM role is a service available in AWS, which it's related to permission management. So using IAM roles, we can control the permissions inside our AWS. So even though you have all the services in your account in the same region, it's not specifically telling you you can use one service in another. So if you're going to use another service in AWS, you should specifically give permission to that. So when it comes to creating training job, we need to use our S3, right? So our data available on S3. So we need to read our data from S3. After the completion of training job, we need to upload our model artifact into our S3. Because of that, Amazon SageMaker needs access to our S3. For that, you should specify an IAM role which giving access to our S3. So in my case, it's already selected the IAM role, but for you, if you have a brand new account, this will be empty. Because of that, I will show you how you can create an IAM role as well. So if you want to create an IAM role, just click on this drop down and click on create a new role. And from this pop-up, there are nothing to change. So you should give access to any S3 bucket. It will be easy, but you can use specific S3 bucket as well. But in that case, when we are launching another training job for a data available in another S3, you should create again an IAM role for that. So if you are giving access to any S3 bucket, you can use this IAM role throughout all of your training jobs. So I'm giving any S3 bucket and click on create role. Okay, so this is the IAM role I have just created and it's already selected here after creating the IAM role. So after that, you should specify algorithm source. When it comes to algorithm source, there are many options you can use. The first one, Amazon SageMaker built-in algorithm. So there are many built-in algorithms you can use. So today we're going to use one of them. Other than that, there are other options like you can use your own algorithms and you can use algorithms from AWS Marketplace. So those kind of options are there, but today we're going to use Amazon SageMaker built-in algorithm. So this one, you can keep it as it is, and then you need to provide which algorithm you're going to use. So for today's demo, I will use k nearest neighbor. So it's something very easy to understand, some basic algorithms called KNN. And if you look at that algorithm, you will simply can understand what is happening and how you can tune those algorithms. So today we're going to use k nearest neighbors algorithm. And after that, other things you can keep them for default, nothing to change. But there are many configurations. When launching the training job, you can provide how much of storage you are giving to launch this training part. So those kind of things are there. So if you are using some real world applications with huge data, you specifically need to provide these storage volumes and all. But today for this small data set, it's not necessary, and these default resource configuration will be totally enough for them. And after that, the next important thing you need to change is hyperparameters. So hyperparameters is the one which provides you to controlling the training. So you will know something called hyperparameter tuning, right? So you can increase the performance of your AI by tuning these hyperparameters. So today I'm going to show you what are the basic parameter values you need to give when you are using KNN algorithm with Bangchun. But when you are using this for your own applications, you can tune them as you want. But today I will go with some basics. So first thing, you need to provide what is the feature dimension. So what is this feature dimension? So if you look at the data set, you should provide the count of your features. So the first column is the label column. So excluding that, you should provide how many feature columns are there. So when it comes to Bangchun, there are 15 feature columns. So I'm providing 15. And after that, you should provide what is the minimum batch size. The default one is 5,000, but our data set is very small. So we cannot go with 5,000. Because of that, I will change it to something smaller, around 100. And the K value is the special hyperparameter specifically come for KNN. So you can tune your algorithm by these parameters. So I'm going with 5, but you can provide any number you'd like. So if you want to know what are these parameters and what are these things controlling in your training, so just click on this learn more link. So I will show you that as well. So in Amazon SageMaker, it has all hyperparameters and what are the things controlling by them. So it has a good documentation. So you can go through this documentation and get an idea how you can tune these things. So after specifying the K value, next thing you need to tell what is the predictor type. So today we're going with binary classification problem, right? So because of that, we need to select classifier. So if you are predicting something like prices and all, you should go with regressor. But today we are going with binary classification. Because of that, predictor type should be classifier. And after that, you should provide a sample size as well. So I will provide 200. And other hyperparameters, you can keep them as defaults. And the next thing, you should provide data channel configuration. So what is this data channel configurations? When launching the training job, you should specifically say where your data is stored and where should your output artifact should upload. So you should tell those things. So the first thing, we need to provide the channel name as train and say where your train data file is located. So my channel name is train and these should be verbose. So when it comes to KNN algorithm, the channel name for train data configuration should be train. So that should be like that. So you cannot give like train, bank churn, so it will going to fail. So these channel names should be verbose. So train is the one when it comes to KNN, and input mode should be file, and content type should be text CSV, and we should provide the S3 location. So that's why I kept my S3 tab open. So I need this location. To get the location of the file, you can click on this file and it will open like this, and there is a S3 URI. So you should copy this S3 URI and you can use it here. Train. So this is my train channel. Like this, you should add another channel for test. So the channel name for test should be test, and input mode file, content type text CSV, and S3 location. So the same location, but test CSV. And after that, we should specify what is the output location. So where should my model artifact uploaded? So I will give the same location, but for a folder called output. So my artifact will be uploaded to a folder called output. So after that, these are the configurations you need to do when launching the training job. After doing these changes, you can click on create training job. Okay, so after click on create training job, it will come to the screen like this, where it will list down all the training jobs you have. So this is the one we just created, SLASCOM workshop 1. And when it comes to this, its status is in progress, right? So it will take some time to do the training. Depending on your data set and the hyperparameter values you are provided, the time it will consume can be changed. So because of the time constraint today, I'm not going to wait until this come to the status of completed. So I will show you a different training job which launch for the same data set, bank churn, with the same hyperparameters, which called bank churn. So this is a completed training job, and status is completed. So after your training job come into the completed states, it will looks like this, and how you can see whether the performance of your algorithm. For that, there is a section called monitor. When you click on your training job and go inside your training job, then there is a section called monitor and link called view algorithm metrics. So if you click on that view algorithm metrics, it shows you what are the matrices reported by AWS in CloudWatch. So test accuracy is the one we need to look at. So you need to tick on that matrix, and you can change the time from here. So my accuracy is 0.76. So it's 76.9 accuracy. So that's the accuracy of my model. So you can launch different training jobs and look at these matrices and get an idea about how well your algorithm is performing. So now we created our training job. So the next step, and after creating the training job, our model artifact will be uploaded to our S3. The next thing we need to create SageMaker endpoint, which will be able to access this artifact and do the prediction, right? So when it comes to creating the SageMaker endpoint, there is an intermediate step called creating model from this Amazon SageMaker training job. So I will explain what is this mean. So our model is already created then, and that model artifact is already uploaded to our S3, but there is a step called create model in this training job. So in your completed training job, next step you need to do, you need to create a model. So when you are telling that create model here, it's not meaning that you are creating a model. This is some kind of configuration part happening in this training job before creating the endpoint. So what's happened in this create model is, now you have a model artifact, right? But there is no way we can look at that artifact and feed our data and get the prediction. So there should be a specific code which can do that part. So which can communicate with that artifact and feed our data to that artifact and get the output prediction from that. For that, we are using a code which available in AWS as well. Since we are using AWS built-in algorithm, those prediction inference code also available in AWS. So what happened in this create model is, we are doing that mapping part. So we are telling this is the artifact location and this is the location for the inference code which can communicate with our model artifact and get the prediction. So we are just creating a configuration in this create model. So you need to provide a name for your model artifact. So I am going with the same name, and you should provide the IAM role, and you can provide the same IAM role which you created in the SageMaker. And other than that, nothing to do change in this configuration. So like I said, it will show you this mapping part, right? So the location of inference code image and the location of model artifacts. We are just giving this linkage in this configuration. So that's the only thing we are doing here. And we are click on create model. So after giving a name to your model, you should click on create model. So after that, it will come to a screen like this, which will list it down all the models you have. So now you have a model. So I will go inside this model, and this is my configuration for the model data location, and it has all training job. What is the training job? So those configurations available here. So now we can move on to our step called SageMaker endpoint. So now we can create our SageMaker endpoint. So I will, okay, so this is the model. So inside model, there is an option called create endpoint. So by clicking on this create endpoint, you can go to the screen of Amazon SageMaker endpoint creation. So now we're going to create SageMaker endpoint. Here also you should give a name, and then you should attach endpoint configuration. So what is this endpoint configuration? So when you are spinning up your instance for your prediction and null, you should specify what are the resources need to use. So those resources and all the things are specified in this endpoint configuration. So you should go with create a new endpoint configuration and provide the endpoint configuration name. And here you can specify what is the instance type and what is the training job. And so you can just click on edit and change this instance type and all. So default one will work with our bank chain scenario, and I'm not going to change anything. So after giving a name to your endpoint configuration, you should click on create endpoint configuration. And this is just only providing the configuration part, like what are the resources we're going to use. Still, we didn't spin up our SageMaker endpoint. So this is the place where you will going to cost money. So if you spin up an SageMaker endpoint, it will going to cost you money. So if it is in service, let's say if it is in service for 1 hour, then you will going to cost for 1 hour. If it is in service for 2 hours, then it will going to cost for 2 hours. So if anybody doesn't want to get charged, just don't click on this create endpoint. If you click on create endpoint and if it is come to in service, it will going to charge from your credit card in AWS. So that's the point I need to highlight here. So I will click on create endpoint. So after click on create endpoint, like the training job, this also will take some time to spin up your instance. So until this status is come to in service, your SageMaker will not accept any request coming for that. So it should comes to in service to accept the request. So it will take some time. So I will show you a endpoint, show you an endpoint which available in service. So this bank churn endpoint is in service, which created by bank churn training job. So I will show you that. So this is in service, so we can communicate with this, but as Nisha explained, this is also available inside AWS, and this Amazon SageMaker endpoints are not accessible by external parties. For do that thing, we going to use an intermediate service called AWS Lambda to trigger these SageMaker endpoints using request coming from external parties. So the next step, we need to create an Lambda to trigger these endpoints. So I'm going to so this is my endpoint. I will keep this tab open because I will need this endpoint name in my Lambda. So I'm opening a tab again. And I will search for Lambda. Okay, so before comes to Lambda, there is another step. So Lambda is going to communicate with our SageMaker endpoint, right? So in that case, so same thing applies here. So we need to create another IAM role here, which gives access to communicate with SageMaker endpoint. So we need to create an IAM role here. So the first step, before going to create a Lambda, you should create an IAM role. For that, you should go to IAM service and you should go to roles and click on create role. And from here, use case is Lambda, since we are going with Lambda. And the next step, you should provide the permission. So what are the permissions we're going to give? So we need to give access for SageMaker. In that case, we will give SageMaker full access. So just tick on this and next, nothing to do. Next, give a name. Okay, I will just give class com and create role. Okay, so my role is created. Then you can go to Lambda and click on create function. Here you should give a name for your Lambda. And runtime, you should choose what is the runtime you're going to use. Today we're going with Python. So I will choose Python 3.8. Then you should provide your IAM role here. So in the permissions, there's an option called use an existing role and provide your IAM role here. Okay, just /com and click on create function. Then it will come to a screen like this, and here this is the place where you're going to include your code snippet related to communicating, triggering your SageMaker endpoint. So I will provide a code snippet for that as well, for triggering your BankChurn endpoint. So for your listeners, I will provide this. I will put it on the chat as well. Okay. Okay, so I just pasted the whole function into the chat. So if anybody wants, they can copy paste it to your Lambda. So I am going to copy paste it here. So after changing your code, please keep it in mind until you are giving deploy, your changes will be not reflected. So you should click on deploy, and there are things you need to do. So in this SageMaker, still we didn't configure which endpoint you need to trigger. So we provided endpoint name as an environment variable. So because of that, you need to configure your environment variable here. And for that, you should go to configuration and edit, add the environment variable, endpoint name, and this is my endpoint name, so I will give that, and click on save. Okay, so my endpoint name is configured, and after that you can provide a test event here. So test event means you can provide and sample input and see whether your model is predicting right. So rather than go to other steps, you can just test it from here. So the next
Yamuna,
step,
just sorry to interrupt. This code that you shared, the runtime code, is there any way that you can share it maybe through a Google link? Because I think we are not able to copy paste it from the chat directly.
Okay. So I will share it from this doc then. Yeah.
Yes,
so,
that would be great. Okay.
Okay. Okay, please give me a minute. Okay, I will provide this reference codes.
And we also have one question coming in. This is coming from Lahiru. So he's asking if we click on create endpoint button, it will charge us. So can we test it without paying?
Yeah, so when it comes to your own application, it will be hard to test on your own if you are not launching the endpoint. So what's happened is today at the end, I can provide the endpoint which I have launched. But other than that, without launching the endpoint, you cannot trigger your model actually. So it's a mandatory step. If you are going through the full AI flow, it should be a mandatory step.
Thanks, Yamuna, for clarifying that.
Okay. So, okay, I will share my screen again. Okay, so in this document also there is a test event. So just copy it, and I will show you how you can configure a test event. So because of the time, I will quickly show how you can do this process. So there is a button called test, right? So you should click on this drop down, and you should click on configure test event. And here you can copy paste your data, and I will give an event name as test and click on create. So I will provide the request as this because I'm giving data, and I provide a sample input from my train.csv excluding the label column. So that's what I did here. And I provided it for something called data because in this Lambda, it's asking the request coming as in a parameter called data set. That's why I put it in that format. So those are the things you can do the changes in your application. So here, this is the line we're going to invoke our SageMaker endpoint. So after doing these changes, I can directly test my SageMaker endpoint by clicking on test. So it will trigger my SageMaker endpoint. So this is the result given by my SageMaker endpoint. So it means my SageMaker endpoint's working fine up to this point. So it's predicted something for you. So my predicted label is 1. So the prediction is 1 means it's predicted as this customer going to exit. So that's what the predictions looks like for this bank churn using KNN algorithm. So I will quickly show you the next step for this. So now we are at this step. So Lambda also something available on internal. So you cannot externally trigger a Lambda function. So you need an API gateway for that. So you need to create an API gateway which can communicate with this Lambda. So that's the next part we're going to do, and that's the last step of your AI workflow in AWS. So I will quickly open another new tab and show you how you can create an API gateway. So you should search for API gateway, and it will direct you to the API gateway service. And here you should click on create API. And today we're going to create a REST API. So just click on REST API, the general one, not the private one. So I will go with REST API. So this is the one which is publicly accessible from the external parties. So I will click on build. And when it comes to here, there are a few steps you need to follow. So these steps are similar to any training job, whether it's bank churn or classification or regression. So anything, these steps will be same. So when creating the API gateway, you should provide the API gateway name. So I will go with the Classcom Workshop 1. And after giving a name, you can click on create API. And then when it comes to here, first thing you need to do, you need to click on this action and create resource. So that's the first step. And you should give a name for here as well. And click on create resource. These are very straightforward steps and will be similar to each and every AI service you're going to create. So the next step is for this resource, you should create a method. So in here, there are all methods available for REST API. In today's one, we're going to provide our input data, which we need to predict. So we will provide input payload, and we will get our prediction as the output. So we're going to select post. Because of that, we need a post method for that. So I will click on this tick. So after selecting post, you should click on this tick, and then you need to provide which Lambda function need to trigger from this API gateway. When request comes to this gateway, it will direct those requests to a Lambda function. In here, we can specify which Lambda function you need to direct them. So I will provide my Lambda function name here and click on save. And it will give some pop-up like this: add permission to Lambda function. You are about to give API gateway permission to your invoke your Lambda function. So just click on OK, because this is what we want to do. And after clicking on OK, it will create API gateway for you. And now you have a public URL which accessible from the external parties for so before getting the URL, still we do the configuration part. So to get the URL, you need to deploy it. So the next one, you need to deploy API. That's where you will get a public URL. So when deploying API, you should select the stage, new stage, and give any name for your stage. And click on deploy. Okay, so now you will get your invoke URL. So this is not the invoke URL. So after deploy API, it will come to a screen like this, and it tells you this is invoke URL, but this is not the invoke URL which you can use externally. To get that external URL, you should click on this blue color arrow, and you should click on this post. If you go to this post link, that's the place where you can find your invoke URL. So this is the complete URL. So if it is working correctly, I should able to invoke my prediction using this URL. So I'm going to test it using my Postman. So I will copy this URL. So and I will provide it to you as well. So you can test it as well. So this is the URL. So you can communicate with this. So I'm going to open my Postman and I paste my URL, and the method should be post, and I should provide a body, a row, a JSON body, which has the input features. So I'm going to copy the same one from here, which available on my test event. So I'm going to copy it from there. So this is my input data. So after that, I can click on send. Yeah, so it's working. So it's predicted the same thing from the external parties as well. So this is the full AI workflow when you need to deploy an AI service and access it from external parties like Postman, external applications, and no. So you can test on your own using the same URL. We're going to keep it up and running for another 1 day or 2. So you can test and play with that. Yeah.
Thank you so much, Yamuna. So that is the full life cycle, and you can kind of see that it involves a lot of small steps, but it is quite doable. And while some of it, like the training and the deployment take about 10 minutes each, and Yamuna kind of had something pre-working, when you actually do this cycle, it takes about an hour or so to get something kind of working. So hopefully that was helpful, and I think we're a little bit over time, so I think maybe we can kind of end it here. And yeah, Andrew, I think, that was the material that we had for today.
All right, thank you very much, Dr. Nisha and Yamuna. I would like to just to give a heads up to all the participants. We will be sharing this recorded session on our Facebook page as well to make it available for everyone, because due to a technical issue, we could not go live. But the recorded session will be made available on the SLASCOM Facebook page, so you can subscribe there and follow us on that. Before we wrap up, if anyone has any questions, I would invite you to, you can turn on your mic and ask a question, or you can drop in your questions in the chat, and I'm happy to pick it up for Yamuna and Dr. Nisha. So I'll just take a moment here. So while we wait, any closing thoughts, Dr. Nisha and Yamuna, for this first workshop session that we had, Dr. Nisha coming in from the AI Center of Excellence as well. What can the participants look forward to as the AI Center of Excellence is progressing in capability development?
Oh, no, that's a very good question. I think the goal of the capability development pillar is to really help people understand how to practically apply and learn AI. And so there's a lot of AI technologies out there, but sometimes it can be a little bit difficult to navigate because sometimes, the news covers things that are extremely advanced. And then people look at it and think, okay, I can't do that, but that does that mean I can do nothing? And so what we'd like to do in sort of the capability pillar is to help people understand sort of different things that they can actually do and learn so that, they can hopefully convert that into actual applications. And that's what we are trying to, do here in this first session with the cloud. Now, the cloud is not the only way to build AIs. One of the reasons we started with the cloud is because it is accessible to a lot of businesses. And so if a business is concerned about, trying to have to buy a lot of computers or set up, internet services or things like that, and a cloud is a very good way to spend a small amount of money and figure out if the thing is going to work for you. And if it works for you, then you may want to consider a larger investment, or you may continue to use the cloud. So that, I think, makes it just easier to get up and running. So.
All right, sounds very interesting. So while you at that, Dr. Nisha, I think there's a lot to look forward to with the AI Center of Excellence. So I invite all of you to, stay tuned to us. I didn't get any questions, but if anybody has any follow-up and wants to get in touch or, clarify anything with Yamuna or Dr. Nisha, please feel free to drop me an email. My email is andrew@slascom.lk. I will also drop this in the chat. Y'all can send me an email if y'all have anything to clarify, and I'm happy to pass it on and get a response for y'all. So that's my email. The A is lowercase, of course. All right. So if there isn't any questions, I think we can wrap up. Thank you to all of you who joined in, and a very big thank you to Dr. Nisha joining from the States. Actually, it's very early in the morning. So thank you, Dr. Nisha, for all your contributions, and Yamuna, thank you very much for taking your time and giving us a very comprehensive and a very detailed explanation on things. So I think that's about it. Wish everyone a very good night and stay safe, everybody. All right, see you.
Thank you, Yamuna. Appreciate it. Take care. Thanks, Andrew. Bye-bye.
Thank you. All right, bye.
Bye. Thank you.